All right, so welcome in everybody. Happy Monday. Welcome into Proportions Part 1. Brief reminder, tomorrow we're doing Part 2. So we're going to get some great practice today. And the three main things that we're going to be doing today as follows, as you can see up here. Number one, got to understand proportions. Got to understand the main idea. And we have to review how to go ahead and calculate with proportions. So that's going to be number one, full stop. So whether you're watching this video or here live, whether you feel like you haven't done math in years or you feel really good about how you can do proportions, doesn't matter. We're going to basically reconstruct that line of thinking, making sure we know what a proportion is, how to spot one, how to set it up, and how to solve it. We're going to get plenty of practice by breaking down word problems. And then on top of that, once we're ready, we're going to get a ton, and I mean a ton of timed practice. So before we get started, if I were to say, hey, we're going to start with timed practice right now, how nervous would some of y'all be? Go ahead, give me a phrase or a sentence. How nervous might you be if I said, we're doing timed practice literally right now, before we do the notes? Alexis says, very. Pretty nervous, very nervous. Me, 7 out of 10, 100%, but let's do it. Full send. My stomach just fell to the floor. Yeah, some of that anxiety, it's real, right? That anxiety can be very real. You know, that nervous laughter. So, one thing that we want to master is strategy. You want to give yourself the opportunity to think positively about this opportunity and not kind of taking yourself out of the game before the game starts. So, I'm going to teach you guys how to handle word problems. But in order to make sure that you can appreciate what I'm about to teach you, I want you to go ahead and try some timed practice out. So here we go. I'm going to just go ahead and put this timer right here, right next to me. You'll see that right there. And let me go ahead and grab this timer, set it up for 2.5 minutes. Perfect. There it is. And I want to give everybody a chance to just try this out. When you have an answer, just type ready in the chat box. Don't reveal your answer. Give everybody a chance to do this. But again, I want you to understand yourself in terms of how you handle this, and then I'll come in and take us to where we need to be. So here we go. Timer has started in 3, 2, and 1. Give it a shot. My face is gone. Do your best. And looking at our final 3, 2, and 1. Go ahead, put your answer in if you have one. Put a question mark next to it if you're taking a guess. And then after I'll ask this after I see all of the answers here. So again, no shame in taking a guess. Treat this like the actual ASVAB. No shame at all. If you're wrong, you're wrong. If you're right, you're right. So go ahead, put an answer in or a guess in. Totally fine. Okay, good. Now, next thing I want you to let me know, for those of you who put a solid answer, that wasn't a question mark. For those of you that put a solid answer, you tell me, are you confident that you can explain your work? Are you confident that you can go ahead and explain your work if I were to go ahead and say, start to finish, tell me what you did, why you did it, and how you know it's going to get you the right answer? Okay, sounds good. So for those of you who are not in my program, let me prove a nice little point that I'm going to make. Strategy works. For those of you who are confident that you got it right, type into the chat box right there, the main idea for proportions. Do me that favor. What's the main idea for proportions? Jones, compare the same things. Zilly, compare the same things. But in what way? Adrian, compare the same things in the same way. Lewis, compare the same things in the same way. Giancarlo, compare the same things in the same way. It's almost like they've been to classes that are similar to this before, and they didn't memorize every problem that they did. They memorized the main idea that allows them to do any proportion problem that they might ever see. That's the point of this class today. In every class, you have to make sure you give yourself a chance to understand the main idea, because that's really where your success is going to come from. Let me go ahead and prove the point here before I give you the correct, or actually it doesn't even matter in this case. I'm going to go ahead and give you the correct answer. It is going to be 50. Had to do the math real quick in my head, but let's go ahead and start off with the notes, and then we're going to go back and we're actually going to work it out to show you exactly every which way you could have solved that problem, and one way you could have solved it in less than 5 seconds after reading it, of course. So here we go. Main idea, my party people, when it comes to proportions, right over here. Main idea is compare the same things in the same way. I want everybody, especially if you're brand new, take your time. I'll give you 20, 30 seconds. I'll ramble for a little bit. Go ahead, just write that down. Compare the same things in the same way. Write it nice and big. Make sure that it is noticeable. Put a star next to it. Whatever you got to do. Because every single word problem that we are going to do today for proportions is going to follow that idea. I'm going to make it real easy for you. So once you have that written down, say got it or ready in the chat box, and I'll give you a couple more moments and we'll move forward. Cool. Perfect. I'll give it a few more moments because I know obviously some people have a couple moments of lag between me and you on Zoom. So I'll give it a few moments. All right. So let's go ahead and move forward here. Compare the same things in the same way. What does that mean, coach? It's actually exactly what it sounds like. If you have a comparison between two things, if you want to set up a proportion, you just have to compare those two things in the same way. So let me give you a nice brief example here, and then we'll move forward to show you exactly how we can solve that next problem. So here we go. Let's read through it. So the ratio of books to pencils is 1 to 10. Okay. If you see 5 books, then you know there are blank pencils. The answer is not so much important here as how we know the setup is correct. So everybody, let's do ourselves a favor. If they say the ratio of books to pencils is 1 to 10, what does the 1 represent? What does the 10 represent? Can someone tell me in the chat box? Both of them. The 1 represents this, the 10 represents that. And how do you know? How do you know? Go ahead, let me know. Let's have this little discussion. What does the 1 represent? What does the 10 represent? And how do we know? Okay, looks like a lot of people here are saying 1 represents the book. Pencils is represented by the number 10. How do we know? Illy, Rodriguez, exactly. The order matters. So everybody take a look at this. If we were to show that we have books to pencils as 1 to 10, look at that. The order matters. One more time, everybody. Does the order matter when you're stating a ratio? Let me know again in the chat box. Does the order matter? Yes, it does. So if you see that it says books to pencils, the first number represents books, second number represents pencils. Nice and easy. So we can go ahead and start that there. That's books. And this right here is pencils. Boom. So everybody hit me in the chat box real quick. Just write got it before I start talking about the next little idea. Good. Drink some water. My voice has been gone for a little bit. Perfect. All right. So when we take a look right over here at the bottom, over here, the top number here, we know that represents books. And then this on the bottom, the 10, represents pencils. So what am I getting at? Well, everybody, the main idea is right here again. Compare the same things in the same way. So if we're going to come right over here and say, hey, we have 1 representing books up top and then 10 representing pencils on the bottom, everybody, before we even look at the remaining part of this problem and the blanks and all that, if we know that we have to compare the same things in the same way and we write books over pencils, what does this 5 have to represent? What does the 5 have to represent? Books. And that's because, again, we have got to compare the same things in the same way. If we saw that, oh, ratio of books to pencils is 1 to 10, and you choose to write the 1 up top that represents books, on the other side, this also has to represent books. It's just comparing the same things in the same way. And so that means this on the bottom, this X that we're looking for, that represents pencils. Obviously, my big old head's almost in the way. We're good. But my party people, before I continue, before we start talking about revealing that answer, is this something that with some practice and some patience, you can definitely come to understand how to compare the same things in the same way? You tell me. Good. Okay. For anybody who is set, and I'm hoping this is every single person here, for those of you who are looking to succeed in today's class, this is where it starts. Knowing the main idea, comparing the same things in the same way. Once I get to the next level of question, I promise you, half of y'all are going to be like, what the heck? I'm so confused. But then I'm just going to come on in and say, let's compare the same things in the same way. And then it's going to be kumbaya, light bulb moments. Oh my God, coach, that's what's going to happen. So we want to make sure that we start with the main idea. Okay. So let's zoom on out and let's prove the point. I got you, Mike. So let me go ahead and let these folks in. But now let's take a look at the other sentence. It says, if you see 5 books, then you know there are blank pencils. Okay, look at that. We were correct. The 5 represents the books, and the blank, the X, represents pencils. We're good to go. We've compared the same things in the same way, and so we know that if we solve this, we are set. So I see Gerald asking, hey, coach, can we cross multiply or simplify? Yeah, we can cross multiply to get this done. Who here has ever heard of that for proportions? Cross, multiply, and divide. Who's heard that before? Yeah, a lot of us have heard that before. Then we can definitely do that here. Everybody, check it out. If I cross multiply, everybody, if I multiply X by 1, What's 1 times x? What's 1 times x? How do we write that? Yeah, 1 times x is just 1x, which is the same thing as just saying x. Anything times 1 is itself. I think we know that. So we can just write x right over there. Now let's cross over here. Crisscross applesauce. Everybody, 10 times 5. You know I'm bad at math. What's that going to be? I'm very bad at math. 10 times 5, that's going to be 50. Okay. Sounds good. We'll write that right over there. And there's our answer. We know that there are going to be 50 pencils if we see 5 books. There it is. And we are good. Now, my party people, let's go ahead and really understand other ways that we can solve this. So before I do, pop quiz, not going to show it on the screen. Everybody go ahead and write down the main idea for proportions for me, please. Do me that favor. Again, my memory might be bad, so what's the main idea? Compare the same things in the same way. Yes, I want everybody to go ahead and write it down. Everybody here, go ahead. I promise you, I know I'm being annoying. I know I'm being annoying. I know I'm being repetitive, but this is the most important part of class because once we can start that word problem practice, it's always going to matter. All right, perfect. Perfect. I know we still have a couple dozen, but there's a ton of people here in today's class. So let's go ahead here and look at different ways. Can we compare the same things in the same way? We absolutely can. Everybody, watch this. Let me just move this over to the side a little bit and move that to the side a little bit. That way I have a little more room to work with. All right. So everybody help me out. Let's compare the same things in the same way. How do I do that? Watch this. Everybody, when it comes to ratios, we are talking about multiplicative comparisons. So multiply or divide, that's how you compare, not adding or subtracting. So everybody, y'all tell me which operation, multiplication or division, and how much. What does it take to go from 1 all the way to 10? What does it take to go from 1 to 10? Yeah, you can multiply and we can multiply by 10. Exactly. So the comparison from the top to the bottom here is times 10. Okay, what does that mean? Compare the same things in the same way. Everybody, if it's a comparison of times 10 top to bottom, what's the comparison going to be on this side, top to bottom? What's the comparison going to be? Exactly. It's going to be the same thing, times 10. So yeah, just to clarify that, ratios are multiplicative comparisons, not adding and subtracting, but multiplication and division. That's what makes it a ratio, scaling up, scaling down. Scaling is the idea, multiplication and division. So here, I got you. So here, times 10. Let's see if we got it right. Everybody, what's 5 times 10? What's that going to be? Yeah, that's going to be 50. And we got it right. And we got it right. So we could compare the same things in the same way. Notice it's times 10 top to bottom over here. It'll be times 10 top to bottom over there. Is anybody looking at that thinking, hey, that seems like something that could be useful to save some time? Is that something you feel like you could use to save some time? Yeah, I think so too. I absolutely think so too. And Arnav, yeah, we did do cross multiplication. We absolutely already did it. We did 1 times x. That's going to be x. And then 5 times 10. That was 50. We also noticed that we can compare the same things in the same way if we wanted to, if it's available, if it's convenient. We saw, oh, times 10 over here, times 10 over here, 5 times 10. That's 50. That works. But we're not done. We can also do this. We can notice left to right or right to left. I noticed that if I want to go from 10 to x, I got to understand the relationship the same way, left to right on the top. If I want to go left to right on the bottom, you got to know how to go left to right up top. Everybody, you tell me, what do I do to go from 1 to 5? How do I go from 1 to 5? Yeah, we can multiply by 5. If we wanted to, times 5 up top. Let's see if the same thing holds true on the bottom. Everybody, 10 times 5 is what? 10 times 5 is what? 50. Yeah. Again, notice what we can do when we follow a main idea, a core principle, instead of trying to memorize questions, hope for the best, only knowing how to do it one way. If this sounds like I'm taking some jabs at you, I promise you I'm not. But this is the reality that a lot of people face that I really need us to go ahead and turn away from if we truly want to be able to succeed. Knowing only one way how to do something, one way to recognize it, one way to perform it, it's going to lead to trouble. It doesn't leave a lot of room for that creativity that a lot of these problems need you to have. So with that, let me go ahead and answer these questions here. So Zubair, what if the question comes that we put 7 instead of 1? So in that case, great question, Zubair. If this happens to be like a 7 or some number that you can't make a quick comparison with, like how do I go from 7 to 5? Right, not very clear. So what you can do, straight up cross multiply and divide. I'm letting you know that if the situation is convenient, there are some places here, there's a lot of room for saving a lot of time. But if that situation is inconvenient, then you got to get prepared, get your hands dirty, cross, multiply, divide, and get it done. Zubair, let me know if that makes a little more sense. Perfect. Everybody else, does that make sense to you? Comparing the same thing in the same way, that can definitely help us save time, only if the numbers are convenient. But we don't want to force a situation if we don't see it. We can always default to cross multiplication and division whenever we want. Sweet. So let me zoom on out. Right there. Perfect. So feel free, everybody, to take a screenshot. These are the main notes. Take a screenshot if you need to. For those of you in the program, the recording is going to be available first thing in the morning, so you're good. And I'm going to mess up at least one person's screenshot here. Got to do it. Perfect. I mean, you guys are coming here to a free class. I got to go ahead and have some fun. So with that, let me go ahead and check out this question here. How did you get the 5 up top? So, Ant, make sure, I mean, if you're working, man, go ahead and watch the recording. But one last time, the 5 comes from wanting to place the number in a consistent place. If we're going books to pencils, then up top over here is books to pencils. 5 represents the number of books. 5 books, right over there. When do you consider, what do you consider a convenient number, Rami or Raimi? So that would be if you see like comparing 5 to 10, you know, that's times 2, or something like 2 to 16 times 8. When you can easily tell what you would multiply or divide to go one way or the other, that means you have a convenient situation. If you have something like 17 and 13, I don't like that. Just go ahead and cross multiply and divide. But if you see something convenient like 10 and 50, oh, times 5, that's pretty convenient. So you want to wait for those convenient situations and recognize them to save time. And we will definitely have some of those for sure. So let's get back to the first question that made a couple of folks' stomach just drop through to the floor. Tough to imagine, but let's go ahead and get this done. First things first, everybody, when we attempt a word problem, what's the safest way, the most calm way to approach this? What do we do? What do we do? What's the first thing we do? RTQ. Well, my party people, if you haven't noticed, we have about 80 new people here today. So could someone go ahead and let me know what RTQ stands for? Yeah, read the question. Appreciate you, Shelby. And I saw somebody else that I can't really zoom on up to see, but thank you. RTQ stands for read the question. There are 3 steps to word problem success, everybody. We always do this. We always start by understanding what we want. Then we understand what we have. And then we build the connection. So what do we want? What do we have? What's the connection? So whenever you see someone say RTQ, that stands for read the question. So right over here, everybody, this is what we'll do. We are not going to start off by reading a recipe for homemade cleaning solution. Like, no. We're going to go straight over here where it says who, what, when, where, how many, which of the following. So the actual question itself, that's where we start. And so we'll start off by saying, how many ounces of water should you use? Everybody, does that make a little more sense to how to start off a word problem? If you start with the first thing being, hey, here's your objective, doesn't that feel like things are going to be a little easier for you? And if you're having a little bit of trouble understanding where I'm going with this, think about any sport that you might ever want to play or any game that you want to play. Everybody, isn't the first question that people typically ask when they are introduced to a new game, isn't it typically, how do I score? How do I win? You tell me, is that something that you naturally ask first thing when you're playing a new game? Yeah, because you want to know how to win. That's what you're here to do. That's what this is about, right? And so same thing with math word problems. Same thing with math word problems. Why would the first thing you do be open up the whole board and study every single part of the board, every single little card you could have there? Why don't you just pull out that piece of paper in there? First line, how to win. That's the first thing we do. Same thing here. Let's understand how we are going to succeed here. In this case, it's going to be how many ounces of water we should use. So everybody, the first thing we're going to do is write this. We want blank ounces of water. You just start off identifying the goal. Now that we know what the goal is, certain number of ounces of water, the next thing we're going to do is go ahead and read through the information so we can understand all of the potential ways that we are relating to the number of ounces of water that we're looking for. So let's go ahead and take that next step. What do we have? We go through and it says a recipe for homemade cleaning solution calls for a ratio of 3 parts vinegar to 5 parts water. Let's highlight that right there. So ratio 3 parts vinegar to 5 parts water. If I write that down, we'll say it right here. 3 parts vinegar to 5 parts water. Everybody, are we good on writing down that ratio there, 3 to 5, where the 3 represents the vinegar, the 5 represents the water? So far, not anything too crazy, right? Just understanding that they said the word ratio, we might as well write it down just to see where we can go with that. Good. And now from here, we have one more piece of information right here where it says, if you want to make a batch using 30 ounces of vinegar. Everybody, the 30 ounces of vinegar, we are connecting that to the blank number ounces of water. Let me know if you see that. Give me a yes or a no, because it's in the same sentence. If we're using 30 ounces of vinegar, how many ounces of water? Those two things are connected because they're in the same sentence, and we're saying, if this, then how many of that? They're absolutely connected. And so I'll say right over here, 30 ounces of vinegar. Hey, right on, Gerald. So here's what I'm going to do. I am going to set up the proportion the wrong way. One more time. I'm going to set up the proportion the wrong way. And what I'm looking for is for you to tell me in the chat box why how I set it up is actually wrong. Again, give me the why. So here's my setup. I'm just going to go ahead and say X ounces of water. And so I have, 3 to 5, and then I'll just go X to 20. So right here, I'm going to go 3 compared to 5 equals X compared to 20. So my party people, y'all let me know. Take a second. Take a second to take a look at my beautiful handwriting, my beautiful work. There's no way I can be wrong. But if I am, tell me why. If I just so happen to be wrong, tell me why. Excuse me, I put that 3 right there for 30. But y'all tell me why that is wrong, with the exception of the 20, because I wrote the 30 now, so no more excuses. What is it? So it's supposed to be the 30? Okay, look, I put the 30 in there. I put the 30 in there. So is it correct now? If I put the 30 in there, is it correct now? Oh, no, it's not, right? It's not. And it's because we are not comparing the same things in the same way. Huh? What does that mean? Let's go ahead and take a look. Everybody, this 3 over here, what does the 3 represent? What does the 3 represent? Yeah, that represents vinegar. 3 parts vinegar. So this 3 represents vinegar. Okay. Everybody, what does the 5 represent? That represents water. Okay, so we have vinegar up top, water on the bottom. Okay. Now let's go ahead and see if we're comparing the same things in the same way. I already see a couple of y'all had some light bulb moments. I love this. So everybody, what does the X currently represent? What does that X represent? That represents the water. So I'll go ahead and write that out right there. And then the 30 represents 30 ounces of vinegar. So we'll write that out. Now, when we said, hey, the majority of y'all said, hey, we're not comparing the same things in the same way. This is what they meant. Zoom on in. Take a look. Take a look. Vinegar to water is not the same comparison as water to vinegar. It is not. If we're comparing vinegar to water, we have to make the same comparison. Vinegar, not water, to water. So what do? Super easy. Super easy. We just take this X, move it to the bottom, take the 30, move it up top. My party people, are we now comparing the same things in the same way? Is that happening now? Boom. So who realized in the middle of me making you tell me what each of these numbers represented, who realized it for themselves that you were like, let me check my notes real quick? That's wrong. Like, who was able to see that as I was working through it? Good. So those of you who are getting to that point where you're sticking to your guns, hey, main idea, compare the same things in the same way. That doesn't look like we're comparing the same things in the same way. This is the start of mastery where that confidence is going to start skyrocketing. Continue doing that, okay? Continue asking, are we comparing the same thing in the same way? Hey, right on, Angelique, I got you. So with that, we are here. We have the proper setup. Who here wants to cross, multiply, and divide? Who would like to do that? Also, quick disclaimer, seems to be quite a bit of thunder and lightning outside. So in case I lose connection, stay in the room. I'll sign back in. Might be 90 seconds to get power back on, so you're good. But you guys would like to cross, multiply, and divide? Sounds good. Let me show you how that will always work no matter what. So here, cross, multiply, and divide. Here we go. 3 times x. Everybody, what's 3 times x? Hit me. 3 times x, we would write that as, 3x, nice and easy. And then cross right there, 5 times 30. What's that going to be? Yep, 150. Good stuff there. So we have 3x equals 150. Perfect. So we're here. We have 3x equals 150. Now the next question is cross, multiply, and blank. What does the blank stand for? Right. We divide, nice and easy. So we'll divide both sides by that 3 to get rid of it. Tell me, my party people, what is 150 divided by 3? Cut that into 3 pieces and we get 50. And there we are, x equals 50. Shout out to whoever uploaded their work in the chat box. That is a first. So great job there. So everybody, can we explain? You tell me, are we able to explain how to get the correct final answer of 50 ounces of water? Do you feel like you could explain how to get there? Good. Good, good, good. Now, you tell me next. Was this a convenient situation with the numbers? Was this a convenient situation to do something other than cross multiplication and division? Absolutely. What is the comparison that you might notice, my party people? What is the strong, convenient comparison that we see? Gideon, yes. On the top, yes. Notice that on the top, let me go ahead and erase this and that. On the top, you might notice that you can go, if you're trying to go from 5 to x, you can use the same comparison as 3 to 30. Notice how we're going from left to right. The same comparison in the same way, it works every single time. As long as your setup is correct. As long as the setup is correct, you're good. So here, 3 to 30, that's times 10. Compare the same things in the same way. Everybody, what's 5 times 10? 5 times 10 is 50. 5 times 10 equals 50. And take a look at the answers. Yeah. So if you notice that, you can save a ton of time and then you can move on, knowing that you're good because you had the proper setup and you're set. Right on, Angelique? Good. So who feels like they are ready to give the next one their best shot? Who's ready? All right, let's do it. So let me go ahead and put the timer up for you. And so we're about the halfway mark. So what we're going to do is we're going to go ahead and get some timed practice, review it, time practice, review, and we're going to continue ramping up. We're going to get to a point where we are going to work on a question that I have and have not technically prepared you for, or maybe you didn't see this exact type. But if you compare the same things in the same way, you're going to succeed. So here we go. Let me go ahead and get the timer up for you. There it is. Get my face out of the way. And here we go, my party people. Let's ace the ASVAB in 3, 2, and 1. Just go ahead and say ready in the chat box when you are done. Do not reveal your answer. All right, looking at our final 4, 3, 2, 1, and time. My party will go ahead, put those answers in. What do we have? What do we have? Put a question mark next to your answer if it is a guess. And let's go ahead and tackle this. Let's see what we got. All right, let's go ahead and get this timer out of the way. Bring my face back into the frame. Perfect. And here we go. All right. So I saw the answers that we were given. Let's go ahead and make sure we could go through each step of the reasoning. So I know there's absolutely at least a couple of folks who definitely feel still a little apprehensive, right? A little nervous about your ability to get this done. So let's focus on our ability to go through the steps. Everybody, first thing I said we should always do is what? First thing we should always do is read the question. Yes, go straight to the question sentence. Ask yourself, what is it that I am supposed to be caring about here? And so we start off with that, and we see that it says, how many pounds of millet should be added to maintain the correct ratio? So that's a big mouthful, but everybody, can you agree that pretty much what they're saying here is we want a certain number of pounds of millet? Are we good on that? Did we all understand that that's what we're looking for here? The number of pounds of millet. Good. Now from there, the next thing we'll do is understand how all of that information up there is connected to what we're looking for, the number of pounds of millet. So with that, here we go. A local farm produces a special blend of birdseed that consists of 2 parts sunflower seeds to 7 parts millet. So if the farmer wants to make a batch using 14 pounds of sunflower seeds, how many pounds of millet? So the first thing I noticed in that first sentence was that it consists of 2 parts sunflower seeds to 7 parts of millet. So with that, my party people, we can go ahead and say 2 parts sunflower seeds to 7 parts millet. Are we good with writing that piece of information down, everybody? I wrote it down correctly, right? 2 represents sunflower seeds, 7 represents the millet. Cool. Sounds good. Now, the next thing, the only thing left to do is to write down that other piece of information that was in the question sentence. And it's, if the farmer wants to make a batch using 14 pounds of sunflower seeds, that's connected to the number of pounds of millet that we're looking for. So here, I'll go ahead and take that 14 pounds of sunflower seeds, and I'll write it in the same color right there, of sunflower seeds. All right. So with that, everybody, do we have everything we need to write a proper proportion? Do we have everything we need? Yes, we absolutely do. Absolutely do. So what we can do is we can say X pounds of millet, 14 pounds of sunflower seeds. Let's see if I can trip some people up. If I wrote it as X over 14, if I read it as X over 14, which number do I have to put on the top on the right side? Which number do I have to put up there? I see a 2, I see a 7. I see some more 7s coming in. I see some more 2s coming in. See 7 and 2. So it looks like there's a debate going on. So I'm not even going to tell you which one's correct. I'm going to let you discover which one is correct by doing the same thing that I did before. Are we comparing the same things in the same way? Well, we're trying to see how we can do that. So let's see what the current comparison is so we can make the same comparison on the other side. Here we go. Everybody, what does the X represent? The X represents what? Yeah, millet. Okay, cool. So we'll write that there. We'll say that's X pounds of millet. And this is sunflower seeds on the bottom. So what we know is that if we're comparing millet to sunflower seeds, Same thing on this side. Same order as well. We're comparing the same things in the same way, in the same order. So here, this has to be millet. Which one of these numbers represents millet, 2 or 7? Which one is it? Yeah, that's a lot more confident now. That's a lot more confident now. For those of you who thought it was 2, do you see how you can self-observe and understand for yourself which one it's actually supposed to be? Are you starting to see how you can see that for yourself? Rodriguez's answer is yes. I gotta turn that feature off. I don't know why all these bubble. I guess it's just Zoom, but good. We see that it's 7 for millet, 2 for sunflower seeds right there. Same comparison in the same way. So we'll put the 7 over here, which again represents the millet, and 2 for the sunflower seeds. Like, this is how we're going to be able to do it, everybody. It's not going to be just doing problem after problem after problem without, having any sort of recourse or, extra time for understanding. It's by doing this in the beginning, making sure that you know how the main idea fits into every single question. So now that we're here, everybody, what do we do? What do we do? I see some people throwing out the answer. I see somebody putting up their work, which is correct. Yeah, we can cross multiply if we want to. We can also compare the same things in the same way. It's up to you, whichever way you want to do it. I can show you over here that we can actually say, hey, if we're trying to get to X, that variable, well, we see that we can try to go from 14 to X. But everybody, what's the problem with that way? If I'm trying to go from bottom to top, 14 to X, is there a really easy way to see how to go from 2 to 7? Is that easy for you? Is that easy for you? No, not exactly. Potentially not if we're working with decimals, multiplying by 3.5. That's not going to be obvious to everybody. So the comparison is there, but it's a decimal comparison, which can make it a little harder for you. So if you don't have the stomach right now for decimals, no worries. Let's see really quickly if we can go the other way. Can we come in from right to left, 7 to the X? Everybody, is there a way to go from 2 to 14? There is. And followed it up by telling me by how much exactly. That's going to be a times 7 relationship. So boom, we have times 7 from right to left on the bottom, from right to left on the top. Same comparison, multiply by 7. Everybody, 7 times 7 is what? 49. Yes. X equals 49. Nice and easy. And if you wanted to, you could absolutely cross multiply and divide. I'll show you what those numbers look like. 2 times X would end up being 2X. And then 14 times 7, 70 plus 28, 98. So you would have 98 right there. And then from here, you would divide both sides. And so that would be 2 on both sides, giving you X equals 49. Boom. So you can do it either way. It just so happened in this problem, we saw that there was a convenient comparison that we can take advantage of to get the answer without having to do all of this. So my party people, who here is starting to appreciate the ability to compare the same things in the same way and seeing the advantage that that really gives you? That's a lot of people. All right, let's go. I love seeing them, man. Yeah, and if you're feeling like you're getting there, you're not quite there yet, that's progress. That is progress. Give yourself the time, the grace. Remember that we want to be patient with ourselves. It's not going to happen on the first time, maybe the second time, but you have to give yourself the opportunity to learn from the previous mistake, so that way you give yourself the chance of avoiding it the next time. That's why I'm really keen on focusing on explaining your work, focusing on the main ideas to give yourself that chance. I got you, Greg. I got you, Ben. So with that, let's go ahead and tackle another question. And after that, for those of you who are interested in the program, I'm going to go ahead and drop tonight's special little promotion for you. I think you're going to like this one. And then we'll continue on with the time practice. It'll take me 30 seconds. but let's go ahead and get ready for the next question. Let's see how we handle this one. So let me get my face out of the way. Here's the timer. And here we go. Again, all I care about is you doing your best. And looking at our final two, 1 and time. Put those answers in, my party people. Put those answers in. Put a question mark next to your answer if it is a guess. Go ahead, my party people. Put those answers in. Put those answers in. Right on, right on. Okay. Okay. So, my party people, how confident did we feel about this one? Scale of 1 to 10. 1 being not confident at all, 10 being super confident. How are you feeling? You let me know. Okay. Okay. Sounds good. Sounds good. I'm glad you guys are feeling confident. I love how we're feeling about this. I saw a lot of you guys put C. It's wrong. It's wrong. So, welcome to the halfway point of class where you're going to want to punch Coach Anderson right in the face, but it's not going to be his fault. So, let's go ahead and understand why that might not be the correct answer. Here's why. Everyone, let's go ahead and go through it. Let's go. Arnav, I got you. Let's go ahead and check it out. Before we get started, everybody, just remind me, please, because I'm not here to, get maimed and run out of town. What's the main idea behind proportion word problems? Y'all tell me. Y'all tell me. What's the main idea with proportion word problems? Compare what? Compare the same what in the what? Compare the same things in the, give me the complete sentence. Give me the complete sentence. Compare the same things in the same way. Compare the same things in the same way. Okay, so looks like we're back on board with that. Cool. So, the amount of violence that I'm facing from some of y'all right now, it's a little lower. Okay. So first things first, let's ask ourselves, what are we looking for? And that's going to be right here. How many gallons of the additive should they purchase? Okay, so we are looking for blank pounds of additive. That's what we're looking for. Okay. Did everybody write that down? That's the goal of the question, right? We're looking for the number of pounds of additive. Yes or no? Is that what we put there? Okay, waiting for a couple more people. I want everybody to reply because almost every single person here got this one wrong. And I want to show you how you can avoid this trap on the test. So go ahead. Oh, excuse me, yeah, gallons. You're right. Been dealing with pounds all day, so I got you. So gallons of additive. Appreciate y'all. Thanks for being patient on that. So how many gallons of additive did we need to purchase? Okay. Next, it looks like, and just write this down now because this is in the same sentence. If a homeowner plans to use 20 gallons of the paint mixture, let me go ahead and write that down right now. So 20 gallons of the paint mixture. Did everybody write that down as a comparison with the additive? Did we say 20 gallons of the paint mixture? Did we write that down, everybody? Y'all tell me, yes or no? Did y'all write that down? I'm seeing some of y'all are starting to self-discover why the 5 is incorrect. Okay, so we have the 20 gallons of a mixture. Okay, now let's take a look at the information that's given to us. It says a paint manufacturer recommends mixing their exterior paint with a special additive in a ratio of 4 parts paint to 1 part additive for optimal weather resistance. So if that didn't make too much sense for you, story time. Hey, sometimes you want to coat your paint on your house in a way, or you want to mix the paint with something else to keep that paint there. Sometimes the weather or powers that be might take things out of the picture. So they're saying, hey, whatever paint you use 4 parts paint, 1 part of this additive, your house is going to be safe. Okay, let's write that down for a moment. We saw 4 parts paint to 1 part additive. Okay, everybody, can you confirm for me that that clearly says 4 parts paint to 1 part additive? Can we confirm that your eyes see that in the story? Can we confirm that? This is where the oh moment is going to come for a lot of people. Ratio 4 parts paint to 1 part additive for optimal weather resistance. Okay, cool. Sounds good. This is what's going to happen if you take the numbers that you have. Because notice, you have 4, 1, 20, and then an unknown. You got 3 out of 4. A lot of people are going to think we're ready to write a proportion. And this might look like what you possibly did if you made a mistake. Some people might go and say, hey, we're going to put X for the gallons of additive. So I'm going to put X over 20 equals, okay, additive was up top. So additive needs to be up top as 1. And then we put 4 on the bottom. Did anybody write it like that? Did anybody write it like that? Yeah, I know. I saw. A lot of people did, right? A lot of people did. But if you're wondering why you're wrong, main idea. Compare the same things in the same way. Are we doing it? Let's see. Are we doing that? Everybody, what does X represent? Hit me. X represents what again? X represents the additive. Okay, sounds good. What does the 20 represent, everybody? What does the 20 represent? The mixture. No, not paint. It's 20 gallons of the mixture. Take a look at the problem again. It says 20 gallons of this paint mixture. 20 gallons of the mixture. So we know that this 20 over here represents the mixture. Now, when you check the other side to see if you're comparing the same things in the same way, unfortunately, It's not going to line up. The 1, yes, that does represent the additive. We're good right there. We see that. That's good. We see it. However, when you talk about the 4 that's right here, the 4, what does that represent, everybody? The 4 represents the paint by itself, not both things mixed together. And so when you write that out, you have a problem, a big one. Because if you continued with this setup thinking, I hope we're good, let's figure it out, let's solve, you're automatically going to get the wrong answer. In this case, it was going to be 5. That was the incorrect answer that you may have gotten. And again, it's because although we are comparing additive to additive, we are not comparing the same things on the bottom. If this is the mixture, this needs to be the mixture as well. So the big question is going to be, how do we get that number, right? Like, how do we actually get that? Everybody, in context, the story of the problem. What did I say? How do we get the mixture? What do we do with the paint and the additive to get the paint mixture? What do we do again? Yeah, we add them together. If we want to get the paint mixture, you add the paint and the additive together, and that's how you get it. And so check this out, everybody. Right up here, let me just move this up a little bit and make your life easy. I got you. So here, if it's 4 parts paint to 1 part additive, how many parts would make up the mixture, everybody? How many parts would make up the mixture? Karl Max says 5. Virginia says 5. Yeah, like I said, to get the mixture, you add the additive and the paint together. In this case, we have 4 parts paint, 1 part additive. So that means it's going to be, in this comparison, it'll be 5 parts of the mixture. And that's where we are. Boom, 5 parts mixture. This is what belongs down here. And so we actually need to remove this. And that's what I'll do. I'll take that out, move it down a little bit, allow that to figure itself out, lagging a little bit. There we go. And so we will actually place the 5 right here. And that will be the mixture. And now we are good. My party people, do you understand where your mistake was made in terms of assuming that the numbers you had were exactly what you needed to plug in? Right on. Hopefully there's a little less anger towards me, right? So just to explain it again, I got you. Just to explain it again, here was the problem. The problem is that we don't want to assume that the numbers we see are the numbers we need. We need to always make sure that we are comparing the same things in the same way. So when I looked at the question sentence, I saw that the comparison in the question sentence for the thing I wanted, it was gallons of additive was what I was looking for. And that was being compared to the gallons of mixture. So again, the comparison right here, everybody, the comparison was additive to the mixture. Before I continue, everybody, especially those of you that are still confused, do you see right here when I wrote down what I needed? This was a comparison between the, again, additive and the mixture, the paint and the additive together. That's the biggest part here. Understanding that first comparison that they give you for the question, the comparison was additive and mixture. Okay, now the same people that were confused, tell me here, that 4-to-1 right here, do you notice that that is not the same comparison? Do you notice that this is actually the additive to the paint or paint to additive? Do you see that? Again, do you notice that it's not the same comparison? Over here, additive and mixture. Over here, additive and paint. Not the same thing. That was the biggest problem here. This is actually going to be not a part to part, like compare this piece to this piece. No, this is actually a part to total question. If you're in the program, you know you've seen this before. And this is exactly what we have now. So let me write this here at the top for you. This is a part to total question, okay? This is a part to total question. My party people, do you see why we needed to add the paint and the additive together to get the number for the mixture? Do we see why we needed to do that? Perfect. Sweet. So again, there's a difference between paint and the mixture. The mixture is when we mix those two things together. Paint mixture just means the paint and the additive mixed together. Typically, you go by that primary ingredient and then mixture after to basically say everything else. So here we are. We have x over 20 equals 1 over 5. We can cross multiply and divide. That'll be super quick. If we do that, we will have right over here. X times 5 is 5x. And then 20 times 1 is 20. All we need is to divide by 5 on both sides. And once we do that, we're set. Cancels out on the left, and we get x equals 4 gallons. And that's actually the correct answer, not the 5. And that's why B is actually the correct answer. And there we are. So who here feels, although they may have been bamboozled, they understand why they were bamboozled and are going to keep a better eye out for next time? Big Brain Bryce, right on. Kelvia, right on. And again, I don't expect every single person here to automatically get it. This is just going to be a basically continuing round of discovery, correction, and retrying. Discovery, correction, retry. And we keep doing that until the point of our normal is constantly succeeding. And so we have to give ourselves that time and chance, and again, that grace to get there. So Arnold, let me just go ahead and check that out here. So it says 20 gallons of this paint mixture. No, we're still good, Arnold. Yeah, we're still good. Because yeah, it does say 20 gallons of this paint mixture. And that means that again, you're adding the paint and the additive together to get the mixture. But nothing else really says 4 parts paint to 1 part additive. So that clearly separates. Hey, 4 is for paint, 1 is for additive. Add them together, that's 5 for the paint mixture or just mixture. Either way. But yeah, paint plus additive is mixture or paint mixture. They both really do represent the same thing. So if it's a problem with just making sure you see those keywords the right way, yeah, take it a little slower, you're good. But that's a great question to ask because I want to make sure that you feel comfortable with what we did. So I'm glad you got it. But yeah, we're still good. Cool. Who is ready for the next one? Let me go and pull this up here. All right, perfect. Yeah, we're good. All right, sounds good. Let's go ahead and do it. And so we're just going to go ahead and go through to the end of class. So again, for those of you who are interested in the full program, you're going to want to stay to the end. Today's going to be a very, very hard to say no to deal. So let's go ahead and pull this timer up. Nice and easy. There's my face out of the way. And let's get it done, my party people. 3, 2, 1, let's go. And looking at our final 5, 4, 3, 2, and 1. My party people, go ahead, put those answers in. What do you have? What do you have? Go ahead. You're doing very good so far, everybody. I'm loving the participation. There's a lot of folks feeling really good about this. Let's go and put a question mark next to your answer if it is a guess as well. Again, we're here to just be better than what we were last time, and we got to put our best foot forward to get there. Right on. So before we get started, how confident are you? How confident are you, my party people? You tell me, how confident are you that you know that you set this up the right way? That you know you didn't get bamboozled by me? You know that you're good? All right, perfect. That's a much bigger ratio, no pun intended, of people feeling better about the problem than they did before. So again, I know not everybody's going to be right there at the place that we want to be, but the point is to get better until we get there. So first things first, everybody, in a word or a phrase, what is it that we're looking for? Yeah, read the question, but once you read the question, what do you know that we're looking for? What are we looking for? What are we looking for? Yeah, how many carnations? If we're trying to preserve the ratio, basically they're saying if we're comparing the same things in the same way, how many carnations are we looking for? So if we check this out right over here, how many carnations should be included? And again, we're trying to maintain the correct ratio. So basically they're telling you this is a proportion question. Perfect. Everybody, yes or no? Do we understand that we are looking for the number of carnations? Good. And notice that in the question, they say, if the florist wants to make a larger arrangement using 45 roses, how many carnations? So that's the giveaway being if we have this many of this, how many of that? That's what's going to tell us that this is a comparison or a ratio being given to us. So boom, blank carnations with 45 roses. Next thing, we go to the beginning of the problem and see if we can find that same comparison in some way. And we see that it says a florist creates a special bouquet using a ratio of 5 roses to 3 carnations. So if I highlight that, the ratio is 5 roses to 3 carnations. So we'll go ahead and say 5 roses with 3 carnations. My party people, sorry, there's not that much space there, but my party people, by writing my information down like this, what's the biggest risk that I'm taking? What's the biggest risk that I'm taking in writing it like that? Who can see it immediately? Chanel, nice. Right. If we were to write it like this, although I didn't officially write the proportion yet, you might see that a common mistake that might appear from this is we're not comparing the same things or writing the comparisons in the same way. Up top, you see carnations first. On the bottom, you see roses first. Definitely possible that some people do that. They write it in the order that they see it and possibly make a mistake. So just to make sure it's nice and easy, we can go ahead and replace this here and there. And now we can just write that comparison and be nice and easy. X carnations to 45 roses is the same thing as 3 carnations to 5 roses. There it is. Everybody, is that proportion set up to compare the same things in the same way? Is that done the right way? Yeah, it is. And we know we're good. And that's where that confidence really comes from. Now that we're here, let's go ahead and solve. There's 2 ways we can do it. One way, cross multiplying and dividing. 5 times x is 5x. 45 times 3. Sure, let's do that on the side. 45 times 3. 5 times 3, that'll be 15. 4 times 3, that'll be 12. Carry the 1 is 13. So we have 135. And then the last thing that we can do is then divide both sides by that 5. Once we do that, cancels out on the left, and we get x equals whatever 5 going into 135 is. So we can do some long division. And for those of you who are screaming at me to take the shortcut, I'm doing this on purpose because I want to show you how much more time consuming something can be if you just missed out on seeing that convenient situation. So 5 going into 135, 5 going into 13 happens twice. You get 10. 3 remaining, drop the 5. Everybody, 5 goes into 35 7 times. So that'll be 27 with a clean division. And boom, 27. All done. But at the same time, this could have been done a lot faster because if you noticed, if we go from 5 to 45, that's times 9. Everybody, what's 3 times 9? What's 3 times 9? 27. And we're done. We can get the same solution, same answer, but if we notice that the numbers were convenient for us, done, easy, and we're good. So Alexa, yeah, so that's the point I'm trying to make with that. Like there's more than one way to solve it, but you just have to be able to notice the convenience if the convenience is there. And so boom, there we are. The final correct answer here will be 27 carnations. For those of us that may have gotten a different answer, do we understand why we got that different answer? That's the biggest thing. Again, even if we make a mistake, we can't control that all the time, but we can control how we approach the mistake itself. How do we learn from it? How do we grow from it? Can we explain? Vincent, let's go. I saw you were a little apprehensive earlier. Love seeing that. Chanel, you too? Right on. Let's go. It's again little wins that it keeps compounding on itself and we'll get that score we want, but we are not here to celebrate yet. Let's get the next one done. Here we go. Let me get myself out of the way and give you a chance to try this next one out. My party people, here we go in 3, 2, and 1. Looking at our final 3, 2, 1, and time. My party people, go ahead. Put those answers in. What do we have? What do we have, everybody? What do we have? Let's go. Let's see. What do we have? Put a question mark next to your answer if it is a guess. And I saw in the comments that some of us are a little confused. And as always, everybody, it's okay to be confused. It's totally okay, especially if you're working, with a tutor or a coach or someone who's trying to help you out. You always want to focus on giving your best shot, explaining every step that you do understand. That way, when we get to the point of that inflection of going from where you were confident to where you're not, we can more easily make that transition. So I just want to ask everybody if that really truly makes sense to you in the context of today's class. Giving it your best shot, doing everything that you do understand as best you can, and then allowing me to help you take that next step. Let me know if that makes sense to y'all in the chat box. Perfect. And I want everybody, because I know there's more than just a dozen here that need that help. So again, be honest with yourself, but give it your best shot as well. Okay, so let's give it a go. Before we begin, is it fair to say that this problem was partly confusing because we have not just numbers in the ratio, but numbers in the names of the amounts, like size 10, size 11. Did that confuse anybody? Did that confuse anybody? Confused you, Virginia, a little bit? Amanda, you as well. Vince, definitely. Yeah, there's a lot more people coming in. So we need to understand what the story is and what the numbers are and what they represent. So allow me to take you through this nice and smoothly. Make sure to pay attention. I'm going to ask you, general questions as we go along. So everybody, we see here that it says, how many size 11 boots are in the warehouse? Okay, everybody, is it fair or is it true for you at least that you knew that we're looking for blank size 11 boots? Is that what you had? That's what you're looking for? The number of size 11 boots? Booyah. Good. And again, you don't need to be a genius here. You don't need to be a genius. Reading the question sentence, again, the who, what, when, where, how many, which of the following. You take a look at that and you know exactly what we're supposed to be finding. Knowing how to get there, that's the game we're playing, but you can't try to get somewhere if you don't know where you're going at all. So anybody can read that question sentence and say, we're looking for the number of size 11 boots. Perfect. Next, let's read the information that's given to us. In that same sentence, it says the ratio of size 10 to size 11 boots is 3 to 5. The way I'm going to write that is like this. I'm going to say, hey, size 10 to size 11, 3 to 5. So we can say the comparison is 3 to 5. And it would be, again, in the order that it was written. We have size 10 right here. And then this is size 11. Is that correctly written? Is the ratio correctly written there? Sweet. So again, the number 10 and the number 11, we're not using that in the proportion. The number 10 is size 10 boots. So you're not going to read 10 as just 10. It's, hey, size 10 boots, size 11 boots. We're not calculating with 10 or 11. It's the representation. Does that give anybody a little more peace or calm as you try to work through this? Does that make a little more sense? Like, we're not throwing 10 or 11 in any calculations here. It's just the representation. You have got to be ready to, if you see a number that represents something, that it's the name of it. It's not the actual number we're calculating with. The 3 and the 5 is what we're going to be calculating with. The only other thing that we haven't written down yet is right here. A military supply warehouse contains a total of 840 combat boots, which are only found in size 10 or 11. So everybody, can you tell me, what does the 840 represent? What does the 840 represent? Pay attention, everybody. That represents total. That represents total. We have a total of 840 combat boots, and we're looking for the number of size 11 boots. Pay very close attention. When I write this down, check this out. I have 840 total boots. 840 total boots. We're looking for the number of size 11 boots. So if we were to write the comparison for the proportion, and if we were to do X size 11 boots over 840 total, what's the problem with this as it currently looks, as it currently is, as it currently stands? Is the 3 and is the 5, are these enough to solve the problem, to plug in? No, it's not. You can't plug in the 3 and the 5. No way you can do that. Sure, you can say, hey, X represents size 11 boots and 5 represents size 11. So sure, I can put the 5 right here. Absolutely. Absolutely. Because you're correct. This is size 11. This is size 11. However, if you look at the 840, that represents the total. Everybody, if I were to throw the 3 in there, does the 3 represent the total? It doesn't. It doesn't. So what that means is if you would have actually plugged in the 3, you may have gotten 1400. This is incorrect. That is incorrect. If you would have put in the 3, it's wrong because it doesn't represent the same thing. The top over here, size 11, that's X right there. X, size 11. So this represents size 11. This represents size 11. On the bottom, 840 represents the total number of boots. 3 represents size 10. This comparison is not the same. We are not comparing the same things. So does that make a little more sense, everybody? Why that setup is wrong? Yeah, the top is size 11, but the bottom, that's total. And here, this is size 10. That's not going to work. Not going to work. Not going to work. The right way to go about it is to ask, hey, if we have total on the bottom, how do we get total with the ratio? You look over here. If it's 3 parts size 10 to 5 parts size 11, how many total parts do we have? How many? Yeah, and that's just going to be 3 plus 5, and that's going to be 8 total. Just like that. Just like that. So, my party people, are we feeling a little better about what the right setup would be and how to notice when we're not comparing the same things in the same way? A little easier there, Jackson. Right on. Vince, I'm glad you see it there too. Again, it's all about comparing the same things in the same way. So now that we are doing that, because we have total here and now we have the total over here, now we can run with it, cross, multiply, and divide if you'd like to, and we're set. If you know the comparison from 8 to 840, that's going to be 105, and then you would multiply this by 105. But if you didn't notice it, you're good, no problem. You can just cross, multiply, and divide, and you're fine. So we have 8 times x, which will be 8x. And then we have 840 multiplied by 5. Let's go ahead and do that. And don't worry, I'll definitely explain it right after we're done again. So we have 840 multiplied by that 5. 0 times 5 is 0. 4 times 5 is 20. Then we have 8 times 5, which is 40. Add the 2, and that is 42. So we have 4,200 right there. And everybody, the last step that we'll take is what? What's the last step that we'll take? Yeah. Divide both sides by 8. And so once we do that, divide by 8 right there, divide by 8 right there. We can do a little bit of long division, see what happens. 8 goes into 4,200. 8 goes into 42. That'll be 5 times because 5 times 8 is 40. Got 2 left over, drop the 0. 8 goes into 20. That'll end up being twice because 2 times 8 is 16. So we have 4 left over. And then we drop the 0 again. So now we have 40. Everybody, 8 goes into 40. How many times? That'll be the 5. Booyah. And there we go. That's a clean 5. 525 is our answer. And there's the answer. But I understand that some of us may not totally be there yet when it comes to understanding how we got the 8 or why we needed it in the first place. So let me highlight the correct answer so some of us can take that screenshot if we'd like to. But let me go ahead and explain the problem one more time. Very briefly, what we had in this problem was we were given 2 different comparisons. One, the answer we were looking for were the number of size 11 boots. Okay, we want to know how many size 11 boots we have. They also gave us the total number of boots that we had available, 840. So first things first, we need to understand that this comparison is size 11 boots with the total number of boots. That should go ahead and kind of raise a little eyebrow on your face because they gave us the ratio right here. The ratio of size 10 to 11 boots is 3 to 5. So this 3 and 5, we can't just throw in here because we need size 11 and we need total. This is size 11, but the 3 is not the total. We need to compare the same things in the same way. So for those of you who are asking, how did I get the 8? Yeah, it's just 5 plus 3, that's 8. That's the math, but the reason is because we needed to represent total with total. That's why. And to get a total of a ratio, well, ratio is just comparing parts. So the total of the ratio is the total of the parts. So that's why we added, because we needed to represent the total of the parts with the total boots. Does that make a little more sense, Gerald? Perfect. I got you there. iPhone, you know I got you. And again, this is where it really matters more to say and understand why than just practice, 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 and move on. Do you guys are we starting to value the prospect of really focusing on one problem, start to finish, the reasons why, over trying to just do 10 problems as quickly as you can? Are we really starting to see the value in that? Good. Good. Like, I really want y'all to succeed. Like, that's what this is all about. So remember, everybody, today's class was part 1. This was all about learning, comparing the same things in the same way. And we saw 2 different types of problems today. We saw part-to-part problems where I said, hey, here's the ratio. Here's one of the numbers. Find the other. Then we also did part-to-total questions like this one, where I give you a relationship of one of the parts and the total, but you only have the part-to-part comparison the other way. So you have to think, get the total so you can compare total to total. Boom. Now, what are some things that we haven't seen that we're going to see tomorrow? We're going to see a couple nice things tomorrow. Number 1, we're going to be looking at triple ratio questions, where it's not going to be the ratio of A to B. I'm going to give you the ratio of A to B to C. And also, in case you didn't notice, we didn't have many decimal questions here today either. And so we're going to up the ante tomorrow as well by adding in questions with decimals, more questions with part-to-part, part-to-total, triple ratio, to really capture everything that you could potentially see for proportion word problems. So who's excited about tomorrow's class? Gonna go punch some walls now, Greg. I love it. I love it. So we had plenty of questions here today, my party people. So we're going to go ahead and continue tomorrow's class again for part 2 in that fashion. And so before you go, I want to make sure that those of you who again are in the program know exactly where to go. And those of you who aren't in the program, hang tight for 2 more minutes, because I'm going to go and show you exactly how we can continue raising those scores between now and tomorrow's class. Thanks for watching my ASVAB party, people. But before you go, if you're here struggling to raise your score, memorizing videos on YouTube, it's not going to do it. What you want to do is join my full program. That way we can help you watch, practice, and master every single step of the way until you get the score you want. It's your career, take it seriously, and that's what I'm here to do. So with that said, my party people, go ahead, reach out to me. There's my phone number right there. Text me, ask me about the program, and I'll show you how to ace the ASVAB. See you soon, my party people. Let's get to it.